right, guys, are there any questions over the homework? What we're looking at today is sum and difference formulas. Sum and difference. Now, the sum and difference formulas really, at this point, don't have as much of an impact or usefulness as they used to. Because again, when we first, or again, we're talking probably in the last 30, 40 years, that a lot of these formulas have become less useful as they used to be. With as fabulous as calculators have gotten, these have become less important. Because if we're talking about, so early 1900s, 1914, and using a lot of trig functions and trying to find values and find angles so that they can, especially if we're talking about 1914, we're talking about war, guns, any of that, and especially for artillery, finding the angle at which they need to shoot the rockets, or so on and so forth, stuff like that. This was helpful because, well, not so much in that sense, but in that time period, these were more helpful because we didn't have the ability to just calculate any angle that we wanted at any given point. We needed ways to get there, and most had, I'm just drawing a rectangle, a chart that had a certain number of angles given to us for sine, cosine, tangent, secant, cosecant, cotangent, and normally they either went to 45, 60, or 90. They only had those values. And they didn't have a lot of the decimal values or half values. So they use these sum and difference, half angles, double angle formulas to get to other angles. So if we wanted to say 135 degrees, we wanted to find out what sine of 135 is, but the graph or chart that we have only goes up to 90. Well, there's ways we can get at that. Because I could say 90 plus 45, and I can find using the sine of u plus v, sine of 90 and 45 to get to 135 degrees. And that's why these were helpful, using these here to get to angles that the charts didn't have. But for us now, we have calculators that can actually do this quite well, do these formulas, and we don't have to do them ourselves. Because if we look at these first two here, again, most of these here, we're going to be able to use the unit circle on. Because cosine of pi over 4 minus pi over 3. Well, this is our difference formula. Grab that sheet hoping to be on the front, but it's not. But y'all have it sitting right there, because cosine of u minus v is equal to cosine of u cosine of v plus sine of u sine of v. And that's just our difference formula. And we do have it up there, but it's, again, you don't have to memorize all these here. I'm not going to make you all do that. That's why I gave you all the reference sheet last chapter that had these. Not last chapter, just a few weeks ago. And all we have to do is input the corresponding numbers. So we're saying that we have cosine of pi over 4 minus pi over 3. It's really saying we have cosine of pi over 4 times cosine of pi over 3 plus sine pi over 4 sine of pi over 3. Now for this one here, if we ended up flipping u and v, it's not going to make a big difference, but for other formulas, we need to make sure that u, since whatever value goes first, it goes in the corresponding u values. The number that goes second goes in place of v, that they match up, because it will give us a different value if we flip them. Mainly it's just going to change the sign, but it is going to be a different value. Now, luckily for us, pi over 4 and pi over 3 are on the unit circle. There are given values. And cosine of pi over 4 is square root 2 over 2. And cosine of pi over 3 is 1/2. Now, sine of pi over 4 is, well, square root 2 over 2. And sine of pi over 3 is going to be square root 3 over 2. We can multiply these together. Square root of 2 times 1 is just square root of 2. 2 times 2 is 4. Square root of 2 times square root of 3 is square root of 6 over 4. And if we wanted to add these together, it's just going to be the square root of 2 plus square root of 6 over 4. That's it. Questions on this here? Yeah, because I mean, we could have, especially with cosine of pi over 4 times cosine of pi over 3, that all out, we could have typed it in. And if you have your little 30xs calculator, you could have typed in because again, these calculators have gotten good enough that they can actually do these here. Questions on this so far? So we figured out what this one is, square root of 2 plus square root of 6 over 4. Yep. Now, if we did them independently, because it's very tempting to just say we're really just subtracting cosine of those values, we're not going to get the same thing. Because as we said, cosine of pi over 4 is square root 2 over 2. And cosine of pi over 3 is 1/2. So really what we're saying is that we have the square root of 2 minus 1 over 2. These aren't the same value. Yeah, because we're looking at negative pi over 12, I think. Because this is 3 pi over 4 minus 4, 12. 4 pi over 12, yeah. So really the angle we're looking at here is negative pi over 12 is what we're finding. Any questions on this here? So, I mean, we could have the same thing with degree values. Because it could be radians, it could be degrees. We'll have the exact same thing. Now, with sine of u plus v is equal to sine of u cosine of v plus cosine of u sine of v. Yeah, with the sine and cosine formulas, sine, they're always sine, cosine, cosine, sine. The signs end up matching. Since it's plus. With sine, if we looked at the one below it on the sum and difference formula, for sine, when the two angles are subtracted, they're actually subtracted in the middle. Cosine, sum and difference formula is cosine, cosine, sine, sine, but the sign's opposite, so when we add with cosine, we're actually subtracting, and so on and so forth. But again, you don't have to memorize these. Now, at this point, we just plug in, because we have sine of 135 plus 35 Let's just say we have sine of 135, cosine of 35, plus cosine of 35, sine of 135. Now sine of 135 degrees, square root 2 over 2. And cosine of 35 degrees, it's not on the unit circle. I have a feeling that needs to be a 45. I grabbed these from the book, making sure that they're not going to give you something crazy on the homework. 135, yep. Sorry, again, let's make that 30. Just for the numbers to work out. Because again, on these here, especially on the homework, they're going to give you nice angles. As cosine of 30 is square root 3 over 2. Yeah. Yep. Nice ability to have an eraser. And again, making sure that you have the angle set up correctly is always important, yes? Because again, when doing this, it's very easy to flip angles if you're not paying attention. Because did anybody else follow what I did? Or did you have it flipped the other way? Yep. Nope, y'all were right. Because I have a feeling most of y'all put 135 and then 30, yes? That's how it should be. Again, even doing this for years, if you're not paying attention, it's easy to flip them. And if something seems off like that, ask, don't just assume. Because again, y'all can do it, I can do it too. It's easy to flip them. Now for cosine of 135, does anybody have a guess of what it's going to be? Yes. Because sine, square root 2 over 2, those always go together with sine and cosine, square root 2 over 2. Now, 135 is in the second quadrant, so this would be negative. And that's one of the things, especially, hopefully you all have noticed at this point, if sine or cosine, one of them square root 2 over 2, the other has to be square root 2 over 2, just depending on the sign. If cosine square root 3 over 2, sine is 1/2. And that's kind of nice, especially with the angles on the unit circle. If one of them's 1/2, the other square root 3 over 2. If one of them's square root of 2 over 2, the other has to be square root 2 over 2. They kind of follow that nice pattern. And at this point here, we can multiply together and solve. Square root of 2 times square root of 3 is square root of 6 over 4. Well, square root of 2 times 1 is going to be square root of 2 over 4, but our sign is going to be minus. And if we wanted to actually subtract these, we can say that this is the square root of 6 minus the square root of 2 all over 4. And the 30xs calculators would have given that to us from the beginning. Because really what we're finding is sine of 165 degrees, which is not on the unit circle. Questions on any of these here? Now again, we can look at just adding the two together. Sine of 135 degrees is square root 2 over 2. And sine of 30 degrees is 1/2. So we're really saying we have square root of 2 plus 1 over 2. These are completely different values. Any questions on any of this here? Question on anything we've done so far? All right. These normally y'all don't like as much because we want to find the exact value of pi over 12. And grab TI30XS. Make sure it's in radians. Say sine of pi over 12. And it will tell us that it's square root 6 minus square root 2 over 4. Yes. Because if we have pi as an angle, or pi as part of our angle, it's a radian angle and not degrees. Now, if we're actually doing this here, using the formulas to find it, not just a calculator, we need to figure out how can I rewrite pi over 12 as a sum or difference of two angles. Sum or difference of two angles. Now, most of our angles that we have a denominator of 6, 4, 3, or 2. So we're trying to see which one of those two would be good with 12. We can use 3 and 4. Pi over 3 minus pi over 4. Now, it's a little bit of a cheat because I already did show us that this does work, because the first one that we did with our radians, because when we put them together, we did see that that works. Or if we say 1/3 minus 1/4, we get 1/12. So really with these sum and differences, when they give us that single angle not on the unit circle, we're trying to see which angles can we use to get to the one we want. So it'd be saying that we are taking sine of pi over 3 minus pi over 4. And for us, that formula that we had is going to be sine cosine. So we'd have sine of pi over 3 times cosine of pi over 4 minus cosine of pi over 3 sine of pi over 4. And luckily this time I did get the angles correct. Now sine of pi over 3 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2 minus cosine of pi over 3. Well, is 1/2. Sine of pi over 4 is square root of 2 over 2. Now if we multiply these together, we'd get square root of 6 over 4 minus square root of 2 over 2, which does indeed get us the square root of 6 minus square root of 2 over 4. Why am I saying that was 2? That should be 4. Questions on this here? Luckily, these are not too bad, especially using your unit circle and reference sheet together. It gives us pretty much everything we need. Any questions on any of this so far? Okay. Let's look at the next one. Find the exact value of cosine of 7 pi over 12. Well, if we look at the unit circle, most all the ones that we have for the different values, because we have pi over 3, pi over 4, pi over 6, pi over 2, the denominators 2, 4, 3, and 6, all do, we can manipulate them in some way to get to 12, yes? What two numbers out of those denominators do get us to 7? 3 and 4, yes? So, and we could try this to make sure. Because instead of subtracting, because we know if we subtract these two, we get 1/12. So if I add them, we get 7/12. And if we include the pi, so instead of saying 1/3 and 1/4, pi over 3 plus pi over 4 would be 7 pi over 12, yes? Let's see here. I wonder. Let's try 1/2 plus, well, it's not going to be 1/6 because that'll be 2/3. No. Because there could be other ways that we get there, because it's just over pi over 2. Because there's not just one way that we could get there. I mean, there's different ways we can get to this here. But 1/3 and 1/4, I say once we find a one that works, let's just stick with it. So we can say cosine of pi over 3 plus pi over 4, which is saying that we have cosine of pi over 3, cosine of pi over 4 minus sine of pi over 3, sine of pi over 4. Now, probably if you already typed it into the calculator, it already gave you the answer, yes? Now, cosine of pi over 3 is 1/2. Cosine of pi over 4 is square root 2 over 2. Minus sine of pi over 3 is square root 3 over 2. And cosine of pi over 4 is square root 2 over 2. And if we multiply these together, we'll get the square root 2 over 4 minus square root of 6 over 4, which gives us square root of 2 minus the square root of 6 over 4. Janessa, is that what the calculator gave you? Or did it say negative 6 plus square root of 2 over 4? Same exact thing. But that's it. Questions on this here? Now, radians, I always find for these here to be the harder ones out of the group to do. Well, because I think y'all find degree measures a little bit easier to work with. Because if we're looking at the unit circle to get to 75 degrees, well, we have 0, 30, 45, 60, 90. Are there two angles up there that can add together or subtract from each other to get to 75? 30 and 45 work just fine. 75, 5. Or if we kept going, we do also have 120 on the unit circle, yes? Either one of those is the exact same, isn't it? So again, there's different ways we can get to this, but once you see one way that works, go with it. you don't have to try to find 100 different ones that work. So we're saying we're taking sine of 30 plus 45. And this here would be sine of 30 cosine of 45 plus cosine of 30 sine of 45. Now sine of 30, because the first one we're looking at is 1/2. Cosine of 45 is square root 2 over 2. Plus cosine of 30 is square root 3 over 2. Sine of 45 is square root 2 over 2. And if we multiply these together, we get square root of 2 over 4 plus square root of 6 over 4, which is square root of 2 plus square root of 6 all over 4. And that's it. Questions on these here? I feel like we feel comfortable with this here, yes? So this here, we want to rewrite as a single term and then evaluate if possible. Most likely we're just rewriting as a single term. We're wanting to simplify and condense this. So sine, cosine, cosine, sine with subtraction in the middle. So this matches up to which is our formulas. Sine of u minus v, yes? So in our case here, u is going to be what? 3, and v is 3 minus 1.2? .8. Yeah, the 0.8. I mean, at this point, we could type it in a calculator and get a decimal answer, but we're just going to condense it down. These are kind of nice. Sine of 2x, cosine of x, plus cosine of 2x, sine of x. This one here, we can't solve because it's not equal to anything. We can't set it as an equation, so we're just going to simplify it. So sine, cosine, cosine, sine. What that's telling me for sure is that it is sine. This is our sine sum or difference formula. And if we look back at it, because there's a plus in the middle, it means we're looking at u plus v. In our case here, u is, and v is. So this here is sine of 3x. Questions on this here? So again, so this one here we want to simplify for tangent. Now looking at this here, there's two places we look for the tangent formula, just to make sure we have the correct one. And it's between the two tangents in the numerator. So we have tangent of 1.1 minus tangent of 4.6. And on bottom, we have 1 plus tangent of 1.1 times tangent of 4.6, because those two spots are really going to tell us which one it is. Now, tangent kind of gives it away that it's going to be tangent sum or difference, because out of all the sum and difference formulas, tangent's the only one that still has tangent left in it. And since we have plus, or have minus on top, plus on bottom, it's telling us that this is u minus v. And u is always going to go first. So it's saying we're having tangent of 1.1 minus 4.6. So we know it's going to be negative 3.5. Questions on any of this here? Find the given value from the given information. Okay. So let's see what we know so far. So we're trying to find sine of u plus v, yes? In the general form, sine of u plus v is the same as sine of u cosine of v plus cosine of u sine of v, yes? So if I want to find out what sine of u plus v is, I need to find out what sine of u, cosine of u, sine of v, and cosine of v are, yes? Okay. Now let's see what they gave us. They told us that cosine of v is negative 12/13. So cosine of v, right here, negative 12/13. They also told us sine of u is 4/5. But they didn't give us the rest of the information, did they? However, they did tell us that v, that should be lowercase, but whatever, is between pi over 2 and pi. So on the unit circle, and again, I'm going to draw a coordinate plane, pi over 2 and pi is in the second quadrant, yes? Our triangles are going to come back. So that means v is over here in the second quadrant. And u, 0 and pi over 2, is over here in the first quadrant. And the reason they gave us this is really to help us set up these triangles and figure out what the values are. Now for v, cosine of v, they told us that cosine of v is negative 12/13. So cosine is adjacent over the hypotenuse. So I'll put the adjacent side, which is 12. The hypotenuse is 13, yes? Which one of those two values will we apply the negative to? The 12. And again, the reason I like doing this, and I should have emphasized this more in the last chapter, is this really helps us with sine and figuring out the values. Because the 12 is on the negative x-axis, yes? So the other side of that triangle, will it be positive or negative? Positive, because it's in the positive y-axis, yes? So that helps us out there. Now, the other triangle, we're told is sine of u is 4/5. So the opposite side is 4, the hypotenuse is 5. And the adjacent side will be positive, yes? It's actually going to be positive what? 3. Because that there is a 3, 4, 5 right triangle, one of our Pythagorean triples. Does anybody know what the other side for the other triangle is? 5. But we can use Pythagorean theorem. So we can say a squared plus negative 12 squared is equal to 13 squared. Or really we're saying a squared is 13 squared minus 12 squared, negative. And then we are taking the square root of 13 squared minus negative 12 squared. And we could have plugged this all into a calculator because we're looking at 144 minus 136. I can write that in the correct order. Sorry, 169 minus 144, which is 25, which gives us a side length of 5. Any questions on any of this here? Now, this may seem like a lot of work just to figure out the other sides of a triangle, yes? But it's actually very helpful, because if we look back at this, one of the other sides we want to find, or one of the other values, is cosine of u, yes? So on this triangle over here, for u, cosine is adjacent over the hypotenuse. Well, we now have the adjacent value, which is 3, and the hypotenuse is still 5. Now for sine of v, opposite side we now know is 5 over the hypotenuse, which is 13. Now we can find its value. Because here we can multiply these together, or really if you wanted to type this onto the calculator at this point, it'd give you the answer. 4 times negative 12 is negative 48 over 5 times 13 should be 95 plus this here again should be 95, and 3 times 5 is 15. So we should have negative 33 over 95, if I did that right. Does this calculator disagree with me? 65. Did you put negative? Okay. Yeah, 48, 95, 15. 65. Yeah. I might be doing something crazy. 65, yes. I see what you're saying. Yep. And I see what I did. Yep. Nope. That's me multiplying wrong, trying to do this fast. Yeah, because 5 times 3 is 15. 5 carry the 1, 5, 1. Yep. That's it there. Trying to do too much in my head. Any other questions on any of this here? We're going to look at one more of these here today, then we will save the rest of this for tomorrow. Now this one here, cosine of u plus v. So this here, our formula, cosine of u, cosine of v minus sine of u, sine of v, is really what we're looking at. Now we are given some of the information already. They told us that cosine of v is negative 3/5. And they told us sine of u is 12/13. So that's what we know so far, yes? I'm going to set our triangle up again. Now for v, v is between pi over 2 and pi. So it's over here. And they told us that cosine of v, adjacent over the hypotenuse, is going to be negative 3 and 5. Now the hypotenuse will always be positive, so the 3 will be our side with the negative. So negative 3. We can go on and finish this out. What's the other side going to be? 4, and it's going to be positive because it's in the positive y-axis. Now u is between 0 and pi over 2, so it's over here. So it's sine, so opposite over the hypotenuse. And what's our third side for this one going to be? 5. Mainly because we did just find it on the last problem, so that's kind of helpful. And that does help us finish out this problem here. Because cosine of u is going to be 5 over 13. And sine of v is going to be 4/5. And again, at this point, you can type the whole thing into the calculator. And hopefully I can multiply 5 times 13 this time. 5 times -3 is going to be -15. Minus 165 on bottom. 12 times 4 is going to be 48. -2. -63 65ths. And hopefully I just got the same thing the calculator got. But that's it. That's all we're doing with this here. Any questions on any of this here? We agree. So we'll stop here for today.